Hello guys, welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science and machine learning. How do we do that? Number 1, we help you build your foundations. We achieve that by making an optimized plan for your learning journey. Number 2, we help you prepare and ace your entrance examinations in statistics and data science like IIT MS, ISI MStat, and CMI MSC data science. Number 3, we give our absolute best to help you design your career by organizing workshops and certified data science courses. To book a trial class for your preparation courses of IIT MS, ISI MStat, and CMI MSC data science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.
Today we're going to solve this problem from CMI Data Science 2022 problem 11. So it says, which of the following plots correspond to a bijective function? So there are 4 plots given and we have to check which one of them or more than one of them correspond to a bijective function. So the plot 1 is basically this. A bijective function is bijective if and only if it is both one-to-one and onto. That means it is both injective and surjective. And what that means is, injective means one-to-one means that distinct elements in the domain must take distinct images, must assume distinct images, right? That's the definition of one-to-one or injective. And onto means that each element in the codomain must have at least one pre-image, right? But at least one. So basically bijection is combining these two properties. So basically it says that every element in the domain is going to be projected into some distinct element, and every element in the codomain is going to be the image of exactly one element from the domain, basically. So here graphs 1 and 4 are actually bijections by inspection. Why? So basically this is nothing. There's nothing to write about, to be honest, at least in an objective problem. So basically, let's check about first check option 2. See this particular graph. See this does not even qualify to be a function. Why? Because it fails the vertical line test. If I draw a vertical line here, it actually intersects the curve at more than one point, right? Which is not supposed to do that, because it disqualifies to be a function, right? So it is not a function if it fails the vertical line test. So obviously it's not a function. So there is no point of talking about whether it's bijective function or not. It is not even a function, right? So yeah, option 2 just gets ruled out. Now option 3, it actually fails the horizontal line test. That means if I draw a horizontal line here, it fails the horizontal line test. Why? Because if I draw a horizontal line, or if I don't even have to draw a horizontal line, here that at the point 0 the function is 0, right? And at this particular point again it is 0. That means it is not a one-to-one function, right? Because the 0 values that you assume both at 0 and this point here must be a point, some real number between some, say, alpha or something. So it does not qualify to be a one-to-one function, and obviously not a bijective function. Now option 1 and option 4, they're both this one is strictly increasing, right? So every element here in the 0-1 domain has a image, right? Every element has an image, has a distinct image, right? Every element has a distinct image. And if I choose any element from this codomain, from this 0 to 1, if I choose any element and just try to produce a pre-image of it, I can do that, right? Because if I choose here, just I draw a line parallel to the x-axis and it touches this curve, and if I just go down parallel to the y-axis, then I get to some point. So every point in the codomain is actually the image of some element in the domain. So it is both one-to-one and onto, right? It is both one-to-one and onto. In fact, this looks like the function of y equals to x, right? Just in the domain 0 to 1. So option A qualifies, and option B is similar. It is just decreasing. That's the only difference. It is decreasing, right? So here also, you take any element in 0 to 1, it obviously has an image, right? And if you take any element from here, the y-axis 0 to 1, it also has some pre-image, right? Some pre-image in the domain. So obviously option 4 also qualifies to be a function which is both one-to-one and onto, and hence bijective. So option A and option 1 and option 4 are both bijective functions, whereas 2 and 3 are not. So option C is true.